Welcome to the first session of the 2022 National Beef Cattle Evaluation Consortium Brown Bagger webinar series, where we're going to focus on updates on tools and strategies to genetically improve beef cattle. Today we have two topics. One is the genetic control of heart conditions of feedlot cattle by Dr. Scott Speidel. And the second is selection indexes for beef by dairy matings presented by Kemp. I'm your host today, Matt Spangler. I'm a faculty member at the University of Nebraska in Lincoln. And I and two colleagues, Dare Bullock from the University of Kentucky and Bob Weber from Kansas State University, co-developed this year's webinar series. And we're extremely pleased to have been able to offer it once again. This, for those of you that have tuned in over the years, this is a very long-running webinar series and one that we think is very important. If you've not done so, I encourage you to visit NBCEC.org, where you can find recordings of previous Brown Bagger webinars. And you can also find what is now the third edition of the Sire Selection Manual. So without a lot more from me, I'd like to introduce our first speaker, Dr. Scott Speidel, who's an associate professor of beef cattle breeding and genetics at Colorado State University. Dr. Speidel is a native of Southern California and has a bachelor's degree from Cal State Fresno. He received his master's from the University of Arizona and then a PhD from Colorado State. Those of you that have engaged in meetings like BIF or this webinar series are probably familiar with Dr. Speidel's work, given his engagement related to the genetic evaluation of beef cattle. And in more recent years, he's focused on things such as pulmonary arterial pressure, and much more recently, in the topic of his talk today, the genetic underpinnings of feedlot health failure. So with that, Scott, I'd like to turn it over to you.
So thanks for the introduction, Matt. I was asked to give you an update on some of the work we're doing here at Colorado State University with regard to this feedlot heart disease. What I wanted to take a little bit of time to do is just give some background on kind of how we got into this, how it relates to high altitude disease as well, because at CSU we've spent a number of years here working on high altitude disease tolerance and PAP testing in conjunction with Dr. Holt and his colleagues at the vet school. So if we get going, there we go. All right. So just some differences between high altitude disease. High altitude disease has historically been a condition or been recognized as a condition that affects cattle at altitudes greater than 5,000 feet in elevation. It was first reported in the early 1900s, and we have a vast resource in Dr. Holt himself, who's taken on this disease in terms of pulmonary arterial pressure testing. High altitude disease is one of those adaptability type traits to where the hypoxic environment at elevation causes a physiological cascade within the cardiopulmonary system of beef cattle in response to low oxygen at elevation. And this causes a change in these animals, and without some type of intervention, they will ultimately die without being transported to lower elevations or what have you. Pulmonary arterial pressure is the selection tool or the metric used to determine an animal's adaptability to elevation or their tolerance. And And here at CSU, we've had a long history of developing PAP EPDs, and our research facility has really been started as the basis for a number of the genetic predictions, commercially available genetic predictions that are being published, for instance, with the one that's currently done by the American Angus Association. So on the other side of that, feedlot heart disease is a similar type of condition that, these cattle have never been at altitude. One of the things that we currently know about it is, we don't know the direct cause. We have some suspicions, internally that I don't think we're ready to really sort of, throw out to the general public yet. But once this cascade begins, the cascade is exactly similar to high altitude disease. The disease progresses in the exact same manner, and ultimately those animals will act like have brisket disease. So, just again in the process, this is the cascade for an animal who develops brisket disease. In high altitude disease, it starts with a hypoxic environment, but you end up getting pulmonary vasoconstriction. Ultimately, the animal responds and to help oxygenate the blood, so to push the blood to different parts of the lung. But that pulmonary remodeling results in the heart having to work harder, creating higher pressures, and then you end up getting essentially right ventricular dilation and right congestive heart failure. So outside of the cause of that alveolar hypoxia, the cascade of events is exactly the same. So if we look at the pulmonary arteries, right, and just to kind of give you an idea on what a normal versus an affected animal, these pictures were given to me by Dr. Tim Holt. And on the right there is a normal pulmonary artery. You can see that it's a fairly large opening or vessel with rather thin walls and that can be elastic at times. But when an animal starts remodeling, as you see there on the left, those walls start to thicken and become rigid. The heart has to work harder in order to push the same amount of volume of blood through that. And so that is essentially what results in that right-sided heart failure. So Dr. Holt has developed a heart scoring system. So we talked about right-sided heart failure, and he developed this scoring system to allow us to calculate observations at chain speed or at harvest speed. In terms of this scoring system, it ranges from a 1 to 5, and the 1 up here, you've got your normal conical shaped heart. You got the right side of the heart. Whoa, let me go back. Whoa. My trackpad is a little sensitive. So you got the normal, you got the right side of the heart. This is the side of the heart that pumps blood up to the lungs to be reoxygenated. Then you got the left side of the heart, the left ventricle down here, which pumps blood to the rest of the body for use in all of their organs and systems. So on a 1, you see that this right ventricle is smaller. The tone it's got good tone, and it's not the largest part of that heart. As an animal's age and as they begin to get larger, we see that the right side of the heart starts to become expanded. These 1s and 2s are considered what Dr. Holt calls variations of a normal animal. So these are just normal aging process of the heart. But once we get into these 3s and 4s here, you start to see that this right side of the heart starts to become larger and starts to occlude the visualization of the left side of the heart. A 4, it's actually larger than the left side of the heart, and we've starting to get this big reverse D, and then ultimately a 5. These are the heart scores of individuals that have actually succumbed to heart failure. We typically do not see these see these at harvest, these animals will have passed some point prior to actual making it to harvest. But what this does is it allows us to collect a lot of data to understand genetics associated with different types of different phases of heart failure disease progression. So we've studied, just a brief history, we've studied heart failure in 3 distinct populations to date. I'm going to talk about in depth about the last one there, which is our most current effort, but we've looked at this in our high altitude adapted commercial Angus population. And then Dr. Milt Thomas led a USDA funded grant to where they were trying to cause heart failure in animals by challenging them with a viral load, and their hypothesis was there was some sort of challenge that started an animal down this cardiopulmonary degradation pathway. But the work in these two, the top 2 efforts, had really led us to our last bullet point here, to where we are really trying to identify or determine metrics that identify cattle predisposed to feedlot heart failure. This is funded by the Foundation for Food and Agricultural Research and their subgroup, the International Consortium for Antimicrobial Stewardship in Agriculture. There's a number of collaborators involved with this. Colorado State University is the lead institution, but we've got RTI, LLC in Brookings, South Dakota. You know, the genetics and the genomics are being supplied by ABS. The cattle are being supplied by Cactus Feeders and High Plains Feed Yard. And then we're also in consulting with veterinary research and consulting services as well. And the objectives are, we've got a number of objectives. One, the primary objective, well, I don't say primary, but we've got a number of objectives. One is to relate pulmonary arterial pressure to heart score. And the second is, if that's heritable, we want to develop selection tools in the form of EPDs, but we really want to understand, you know, the relationship amongst heart scores and heart disease and the genetics of its incidence and all the other different types of phenotypes that are routinely recorded on these animals throughout their lifespan. So just to jump right in, so these are the data that we've collected to date as a result of this ICASA grant. We've collected, we just started year 2. We've got, you know, just over 1,400 head of cattle who have had heart scores. We've got various PAP measures on each of these because PAP is rather costly to collect, so we don't have nearly as many PAP measures as we do of the other phenotypes. But we've got a number of late feeding period PAPs, so just about 350. We've got some early feeding period PAPs, and those at running right at about 178. And I'll talk a little bit more about that and the difference on why those numbers are there. But we're collecting, in the case of the cactus data, we're collecting back fat, marbling, you know, all the carcass traits. We've got various numbers of average daily gains and dry matter intakes, feed conversions, and those types of data. If we think about the incidence of heart score, though, these are just a bar chart representing the counts of heart scores, heart score groups. So if we think about the 2, you know, we've got a majority of 1s and 2s, and then we've got a number of 3s and 4s as well. It really sort of surprised us when we started this data collection effort that we had almost a third of the animals coming through were in some form of heart failure at the time of harvest. So that really sort of led us to the, you know, the idea on, you know, what's kind of happening subclinically in terms of performance, although they are making it to harvest, right? So all of these animals made it to harvest. You know, what are the implications on their ultimate carcass performance and feed yard performance for these animals that are in the throes of heart failure at that time. So what I've got here is a little bit of a noisy table, but we're just sort of breaking down those phenotypes again by actual heart score. I'm not really getting into statistics. I'm showing just, essentially averages and standard deviations here. But some of the things that I wanted to highlight are in these boxes are we're seeing that PAP, particularly this late feeding period PAP, are showing is increasing with regard to heart score. So in those animals that are farther along in terms of their heart score category, they do have higher PAPs than animals that have more normal hearts. In terms of carcass characteristics, there's a mistake there. If you can just look at the above line there for marbling score, we see that marbling is decreasing. So the quality grade, as these animals are moving through the stages of heart failure, their quality grades are decreasing when compared to healthy animals. And then if you look at the ribeye areas and heart carcass weights, I don't mean to highlight that average daily gain, we're shifted off one level here. So I'm looking at particularly between ribeye area and carcass weight, we're seeing trends for decreases in ribeye area and hot carcass weights for those extreme 4 animals. And so this kind of begs the question on, where do we, what's the chicken and the egg here? Is heart failure are these animals suffering so it's causing this decrease in performance, or is there something else going on? And these are really things that we don't know a whole lot about just yet. We're still trying to sort of pull apart these differences in terms of all of these data points. But with regard to PAP, again, PAP and heart score, this is a subset of the data, but I think it illustrates our late feeding period PAP and its relationship with heart score. So as animals increase in heart score, so 1s, 2s, 3s, and 4s, we're seeing that PAP is steadily increasing with respect to those heart score categories. But this also led us to ask the question on what's happening to these animals as they move through the feeding period with regard to PAP. So what we're doing in this study is we're PAPing 200 animals twice throughout the feeding period. So we're PAPing them just right before they go in or right as they're entering the feed yard, and then essentially, about a month before harvest. And so, we've got 1 year's worth of data on these animals where we've calculated not calculated, but we've got 2 different PAP measures. In this first year's worth of data, we had a very tight relationship with PAP, so there's not a whole lot of variability in those PAP measures, and not any of those animals would have been considered to be at risk for that PAP measure at that elevation. However, once we get to before harvest, we see that variation, those animals are starting to expand. And that's been shown in a number of different data sets, and that data set that Dr. Milt Thomas had with his USDA grant that he was working on that I mentioned briefly earlier, saw the similar relationships with the PAPs increasing as we go along the feeding period. So is that a function of age? Is that a function of just the feeding and animals becoming larger? We don't really know yet. But what's interesting with regard to these sequentially measured PAPs is if we break this out by heart score, we see here in this PAP 14 as we see large increases, this sort of exponential relationship in terms of the PAP variability with regard to the different heart scores. So the animals down here are still staying pretty tightly together around the center of that distribution. And then as we move forward in terms of our higher heart scores and all the way out here to 4 in that purple bar, they're really expanding. So, we're kind of asking is, what's causing these animals to be sort of hyper responders with regard to development of heart score and PAP, and then the animals down here that tend to, be sort of, stay consistent all the way across the feeding period. And that's something that we're hoping to answer upon conclusion of this project. But with regard to genetics, I just wanted to take real brief mention, what we know about PAP. And so we're assuming that PAP is related to heart score. And, we've done a lot of work with PAP at CSU, and we know that PAP is really highly polygenic, and there's a number of, these are complex physiological conditions, and there's a number of genes that influence this, and there's really no single gene with overriding effects. So, our ultimate goal is really to determine a heritability. So we know PAP is moderately to highly heritable. Depending on the population, we see heritability ranging anywhere from 0.3 to 0.5. So that means that 30 to 50% of the variation we're observing in pulmonary arterial pressure, we would expect 30 to 50% of that variation to be due to variation in breeding value of the individual animals. So, that really sort of gave us some hope, trying to understand a relationship between what we should expect for the genetics for heart score. And so I'm just going to touch on this really quickly. This was some data that our grad student presented at BIF last year in 2021 in Ames, Iowa. And so what we see are really sire differences in terms of their progeny's heart score. One of the things that we found that was interesting, we didn't have enough data at that time to do really much true quantitative genetic work, but just including sire as an effect on progeny, we can see that there were sires that only had progeny who had heart scores of 1s, and then we also had sires whose progeny averaged a 3.4 heart score. So there's quite a bit of variation with regard to sire's potential for heart score. Now, stepping on to the data we've collected more recently, so we've got 1,400 heart scores, and Isabella has found a heart score heritability of 0.34, meaning, about 34% of the differences that we're observing in heart score are due to differences in genetics, and I think that that's pretty similar to some of the other estimates that have been put out there more recently in some of the literature and publications, beef industry specific publications. So, we're really encouraged by this estimate and how similar it is to the other estimate that's out there right now. You might be asking, is 34% that big of a difference? Well, if we think about traits that are currently or commonly sort of receiving selection pressure throughout the beef production system, this is sitting right in the range of all of those heritabilities that are currently being selected on or being included in different breeding objectives. And then in terms of trends, how much effort can you make? And this is, I'm picking on Red Angus here, but they have their trends easily for me to find on their website. So, in terms of weaning weights, a weaning weight heritability of 0.23, we're still seeing genetic progress across time. And then if we go on and we look at things like ribeye area or marbling here in the blue line or ribeye area in this sort of grayish brown line, our heart score heritability, you can make selection, you can make selection decisions, or in this case, I guess you're more of making culling decisions rather than selection decisions on which sires could potentially have problems with their progeny in the feed yards. So, what we have so far is really encouraging to us. So just to finish this up, and I know we had some problems here on the early on with the microphone and everything, but we're seeing a relatively high incidence of hearts where remodeling has started to occur. And in this study, we had 29% overall. PAP, what's real important to us is PAP is showing a relationship with heart score. And, we need to do some more work with, what does yearling PAP look like? Because that's when seed stock producers typically measured PAP on their replacement animals anyways. So what does yearling PAP look like? And that Heffernan study up here where we've got the 21%, that is, we've done some work with yearling PAP, and there is some relationship there. So, but how effective is it across, in a larger scale and at various different elevations is something that needs to be studied. We're seeing trends of increases in heart score. I didn't have much of that data in here, just given the short amount of time. But, in terms of decreases in efficiency, so depending on the study, whether your efficiency is related to dry matter intake or average daily gain or some sort of feed to gain ratio, increases heart score tends to show more inefficient individuals. We're also seeing indications of decreases in carcass merit or carcass characteristics with increases in heart score. And then really with regard to genetics, we found that differences among sires exist and that heart score is heritable. And this is a sort of backed up other work out there. So, still to do on this project, we've just started year 2 of data collection, and we've got a large focus on beef on dairy animals as well. So we're beginning to collect more data. We've got a big project out at High Plains right now where we're going to be collecting, heart scores on about 2,500 beef on dairy animals this fall, and then just to sort of start pulling out the differences between phenotypic and genetic relationships between heart scores and pulmonary arterial pressures and carcass and intake and then, the use of genomics for this project as well. So that's all I have, and told I was take 30 minutes, but so maybe we'll have some time for questions at the end.
Thanks, Scott. If you would, let me check the chat quickly. So for participants, if you have questions for our speakers as we go through, please use the chat or Q&A. Maybe just a quick question for you, Scott. Have you, I understand there's expense, but have you considered serial slaughter at all as a means of trying to understand when these issues begin to manifest?
Matt, that's a great question, and it's something we've considered because when you think about the heart score, it's kind of it's a rather crude measurement, right? And so it's real easy to sit there and look at a score and say, these are the specific points that makes a heart score of 4. But what we really don't know is where that animal is in terms of, are they just getting into that heart score of 4, or are they, at the end, because we're assuming there's some sort of linear progression in terms of moving from score, a score from 2 to 3 to 4. So we have thought about how do we sort of flesh that out, and that serial slaughter could be an idea. The question is how do you identify? Yeah, I think that would take some more work, but that would be one way of getting at that. Yes.
All right. Thank you. I think we'll move on to our next speaker. But again, please use the chat or Q&A for questions for either of our speakers. We'll circle back to those at the end. And Scott, if you have the opportunity to take a look through the Q&A, you might be able to answer some of those now.
Okay.
So our next Next speaker is Chip Kemp. Chip is currently the Director of Commercial and Industry Operations for the American Simmental Association and International Genetic Solutions. Before joining ASA and IGS, Chip was an instructor at the University of Missouri in the Animal Science Department. And before that, also worked for what would have been then, I believe, IBP, now Tyson, if I have that correct. And so the point is that Chip has a wealth of industry experience, and we're happy to have him visit with us today relative to beef on dairy indexes. So Chip, before I pass remote control on to you, if you would unmute.
Done. Can you confirm that you can hear me, Matt?
Yes.
Okay, very good. Well, one of the things Matt asked me to do was go quickly, and he knows me well enough to know that that can be a challenge, so I'll jump right in it. But one of the things I do want to be clear about is that this discussion is not really going to be a justification for indexes in the beef on dairy space. I think that's reasonably a given. If you're looking for something like that, and I can certainly understand why you might be, there are resources that can help you there. One, it's a little bit of a mouthful, and I don't have it on the screen, but you could go to internationalgeneticsolutions.com/Y indexes. internationalgeneticsolutions.com/Y indexes. It'd give you 20 minutes of a very thorough explanation of the justification for indexes. But if you were to listen to that talk, or pretty much any other talk on indexes, you would hear that essentially indexes are genetic accounting. Our savant in our firm would use that term fairly frequently, and is that genetic accounting is what an index can do for you. So to me, the question isn't do indexes make sense in this space? The question is, are we good accountants? And I think that's what we'll discuss here for a few minutes. So just a quick update. I know many of you know these things, but some might be joining who are not maybe don't have as much reason to keep up with some of the semen trends. I'm going to throw those up real quick so you can see them. And we're going to look at a combination of domestic sales and custom collection numbers from national animal breeders. And these are certainly the gold standard in this space. And when you look, this is the trend over from 2013 to present that we could see in the dairy business. And if you look at that trend, you can see what's happening. Dairy semen's down about a little over 8 million units. Conversely, if we go over to the beef side, this is what you see in the beef equation. And again, same time frame, and you can see that beef semen sales is up 10.25. Now, some might argue that, man, there's been a massive uptake in beef semen in the native beef population. You could probably argue that. I'm just not sure many folks would track with that contention. I think what you really see is when you look at both of those together, the blue line being the total for dairy semen sales and the orange for beef semen sales, I think they paint a pretty clear picture. Somewhere around 2017, the folks in the dairy business started to make a shift in the way they do things. And again, if the argument might be from some is, well, I've heard in the last number of years that the dairy business is going through a massive amount of consolidation, and it is. From an industry, they're experiencing consolidation that makes the pork consolidation of my youth look like a pup, but it hasn't decreased the number of dairy females. In fact, that yellow line is the total number of dairy females per USDA, and in fact, numerically, there's been a slight increase. So I think what's reasonably clear, there is a little extra semen being sold at present, but overwhelmingly, this is beef semen going into dairy cows. If you weren't familiar with those trends, this is pretty well established in the beef on dairy space. So if we're going to predict these sires, and the folks who are listening to this talk, you know these things pretty well. I told you in the beginning, I'm not going to justify indexes. So to a large extent, I'm not going to try to justify genetic evaluation. I think the bulk of the folks watching already accept that. We know these are the things we need, right? Give us some pedigree information, performance on ancestors in an individual, and DNA, which is all the rage, and man, we're golden. And we understand that pretty well. And that gold standard is an index. And the things we want to consider, make sure that those indexes are robust and credible, and that they appropriately look at breed complementarity in the situations that matter. And so the index is the gold standard. Again, that's not my job to convince you of that. Here are a few firms who are engaged in this beef on dairy indexing conversation. We know Angus has both a beef on Holstein and a beef on Jersey that you can view. Our friends over at ABS have some internal efforts that certainly they've been working on maybe as long, if not longer, than anybody in the business. Some of you may be familiar with the Wholesome effort that we've done with Holstein. I'll briefly kind of give you a little bit of understanding of that from our vantage point. And so the history of that first associated generated beef on dairy index, which was the Wholesome index, just a quick history on that. So in 2018, we all know that beef on dairy knowledge was quite minimal. It's only 4 years ago, but we didn't know very much. And the data populations were quite small. And around that time, we'd had a number of folks coming to us asking for some guidance on what sire types might make sense in high Holstein populations. And for those of you who might not have reason to know, the two populations that overwhelmingly make up the dairy space in the US are Holstein and Jersey. And there are a number of composites of the two, but the Holstein population does make up a huge component of the roughly 9 million cows. And so when those folks were coming to us at that time, there just wasn't a lot of data for people to pull on. So we had to start doing a little investigating. And so we did what maybe some politicians, as painful as it sounds, we did a little focus grouping. And so we put together folks who we felt were credibly invested in this and would share and give us some insights. We actually had a major packer who shared a massive amount of their Holstein knowledge from a carcass standpoint. Some of the feedlot partners they work with shared, some operators, and so on and so forth. And so through that focus grouping, we came down to what now might seem kind of duh, but at the time was a little bit crude and a little bit unknown. But the most important measures for folks in the conversation were marbling, ribeye size, carcass length, cavities. Those were the areas that got the most attention in that focus grouping. And so what we did was we took a quick look across the entire IGS database to provide a little bit of a threshold look on those traits. And the answer was pretty clear. We took a look, again, using those some thresholds that were set up as you see there. Top 25% for ribeye, top 25% for marbling, top 25% for cavities, and then more of a mid-level percentage for yearling weight and carcass weight based on some of the carcass length concerns associated with Holsteins. And so we looked across the IGS database, and then we also looked across another large beef database. And what we saw when we looked from a threshold standpoint were results that looked something like this. There were some straight British cattle that kind of fit those thresholds, but it was a reasonably small group. There were some straight continentals, again, a reasonably small group. So roughly 90% of the cattle that at least worked through that initial fairly crude threshold approach were composite bulls. And I don't think that would come as a huge shock to anybody thinking of some of the terminal challenges of a Holstein female. What probably came as a little bit of a shock was of that particular set of 90 some odd percent of the composites, a large portion of them fell within a given population. So roughly 90% of the 90% fell within that Sim Angus population. But that also clearly means there are a lot of bulls from other populations that were worthy. There just happened to be some critical mass in the Sim Angus space. But the real takeaway from that, again, is just to remember that what that initial look showed was the answer for these cows, composite sires. And so thresholds are lovely, but that's not genetic evaluation. And so we dug in a little deeper, and we used a tool some of you may not be familiar with, or some of you hopefully are. That's the IGS feeder profit calculator. It's a pretty sophisticated terminal metric tool. We're not here to talk about that. You can investigate that, or we can talk about that at a later time. But that tool has proven itself to be pretty effective at identifying the terminal metrics of native beef cattle. And so we brought it to bear in this space. But there were some challenges because that tool doesn't incorporate some of the pieces that were needed to identify in these cattle. For example, ribeye area in the native beef population has certainly at 2018 had reasonably minimal impact. You can maybe argue today, post-COVID, as carcass weights have just really taken off, maybe ribeye area has a little bigger impact in the native space when you get up there at 1,600-pound carcasses, just where the yield grade equation works out. But in general, it's not nearly as important as it is to compensate for that Holstein or the Jersey female. Body length, excuse me, there's certainly a challenge there. The Holstein influenced animal can get quite large physically, and on occasion, especially if a feeder early in the feeding phase needs to cheapen up the diets and avoids concentrates at all, there's the potential for those cattle to get pretty long. And so we incorporated some adjustments relative to body length due to some measures that were found in literature. And then of course, calving ease is not factored into the IGS feeder profit calculator at all, because it's already just looking at weaned calves and their value. And in this case, while the instance of dystocia does not seem to be distinctly higher in the Holstein population than maybe it is in the bulk of the native population, the economic impacts of that dystocia on any given female are much more significant because of the dollars invested in that female. So whether it's obvious signs of dystocia or it's just subclinical dystocia that impacts lactation for a few weeks, calving ease just has a different role, even in a terminal metric in their model. So we considered that, and we generated an index that I'm not here to go into much more detail other than to give you a little background on it. You can go look into the Wholesome Index if you want. You can view it on Holstein's website. They have some information there on the sires that make that up. Interestingly enough, just the raw correlations, no genetic correlations here, but interestingly, it tends to correlate a little better with an all-purpose index in our case than our terminal index. And at first that might strike some as a little bit odd, but when you take into account that we're trying to prevent train wrecks in body length, if you're not familiar with what those train wrecks can look like, if you're the person owning those cattle and they get rejected at the plant, trust me, it can be brutal, or some of the calving ease concerns. When you look those things, that is why it ends up, though it's calculated completely differently, correlating a little higher with API than TI. And you should know, ASA, Simmental Association, is actually presently working towards public-facing versions of a beef on Holstein and a beef on Jersey index. That's all lovely. IGS is a group doing wonderful things. Lots of carcass records coming in from this space. Some of those have genomics, clearly not enough, but many. We're able to calculate some genetic understanding for the slivers of Holstein and Jersey that we have in our database. That's certainly informing our processes. And again, we have indexes coming soon. And I would contend going forward, folks in the dairy space who are very keen on indexing, who certainly like whole life cycle or whole enterprise indexing, I can certainly see a day when they're going to try to incorporate some of these terminal metrics into whole life cycle indexing. But the whole point of the conversation going forward is a little bit different. Those are all great things, whether it's at Angus or ABS or the things we're doing at IGS and through specific breed associations like Simmental and that are in IGS. Those are great. But here's where we start to ask some questions that I think are very, very important and pertinent relative to this discussion. Because I ask at the beginning, are we good accountants? And we've made massive advances in our understanding of the beef on dairy space in just the last 3 or 4 years. I don't think anybody would question that. On the other hand, how effective are some of our tools that work really well in the native beef population, how well are they working on the beef on dairy space? And I think what we're starting to find is, gosh, you can listen to Ty Lawrence talk anytime you want from WT about the USDA yield grade equation, and he would probably, I don't want to put words in Ty's mouth, but I think he would debate the effectiveness of that tool to evaluate yield in native beef cattle. I think what Packers, well, I don't think, I know what Packers are seeing is its ability to predict that in beef on dairy cattle is woefully inadequate. In addition, the concern surrounding livers in the beef on dairy space is another massive challenge. We know these things. What do we need? For us to effectively build the next version of beef on dairy indexes, we got to all be honest. We need a lot more phenotypes. We need a lot more phenotypes. We're going to have some level of sustainable structures to relay those phenotypes. And there's a lot of desire to live in silos on this particular discussion. A lot of firms seem to believe that there's a bunch of magic beans here if they can control them all, and good on them if they can. But I would contend we will all make those commercial beef producers, in this case, those dairymen and dairywomen who are making commercial beef calves, we'll make them more profitable if we're willing to share a bit. And so some of the challenges that people are sharing and some of those opportunities. Again, we don't have much data, but the nice thing is lots of folks are chasing this thing right now. So ultimately, I would suspicion that's going to overcome itself. One area I've not mentioned, and that's the concept of male fertility. And we all recognize the level of importance that is across our business, but in particular in the dairy space. And the sad part is there's just not much work done there. But we have some folks who are trying. A&M is just looking to start a new project. That'd be George Perry, K-State, and Megan Roth has been working on that for a while. So hopefully we get some answers that are worthy for genetic eval in the near future, not just some of the anecdotal stuff that is valuable potentially, but it's hard to use from an evaluation standpoint that you might get maybe from a semen company or something of that nature. Another area I've not touched on, and I've only seen one study that suggested this, but one of the Texas Tech studies has shown that there was a little added gestation length in the beef on dairy calves. Again, that's something I think that we're structured pretty well to ferret out over time. I throw this in there. It might look as I've jumped a little bit, but I just throw this up there. This is nothing more than the graph of quality grades in this country over the last 12 years. It's a bit of a chicken or the egg thing, right? Seed stock folks have made cattle that are much richer meated, terminology, higher marbling with a lot more genetics for intramuscular fat. That's been driven by this back and forth with the packer incentivizing it. We can see where they went. The orange line is choice, blue line is prime, and we can see the gray line or the select line is trended downward. I think for the most part, we know this is a pretty well-established trend. So since packers and the rest of us kind of have this interplay, this feedback loop, we certainly do want to consider those folks farther down the line at the feedlot and the plant. Where are the challenges on the beef on dairy cattle? We know they don't grow quite as well. On the other hand, this is easy to address. We know how. And there are certainly some studies out there. Again, Tech would have some studies that show that for a certain subset of the beef on dairy calves, performance and efficiency are not nearly as woeful as you might think. It's just at this point, we don't have a very good model within genetic eval to consistently predict those. In this space, program requirements for some of the certified programs, CEB and the like, you have to be sensitive to colors and markings, but again, those are not overwhelming challenges. Here's where the challenges lie. Liver abscesses all the time. If you're not somebody who's involved in this conversation at a high level or very often, this is the first thing that always comes up without exception. And I'll highlight that here in just a moment. And then the other thing that always comes up without exception is the inadequate ability to measure the red meat yield on the beef on dairy cattle. Essentially, by that I mean that ribeye area does not fully quantify the level of red meat available or the composition within that carcass. And so that's a continued concern. The reason that's a concern, and the packers are aggressive about finding methods to overcome this, is arguably they're overpaying for some of these carcasses because the ribeyes can look sufficient, yet because the rounds and the chucks do not bring the same amount of product that level of ribeye would suggest in native beef cattle, ultimately there's a level of actual product that never materializes from some of the beef on dairy carcasses as they work their way through the plant. So I went to a few folks that I work with frequently in this space, and I went to 3 meat scientists who are very tightly connected to the packers and their concerns, because I do think it's important for us, much like you heard Dr. Speidel talk about Dr. Holt and his work. I think it's really important for us to always go back to the folks who are really living this day to day. And I visited with 3 researchers. I only got 2 of them on the screen. One, Dale Warner, you can see Dale's top concern. I asked him to give me their top 2 concerns as they see it in the beef on dairy space. You can see they both, Dr. Warner and Dr. Scott Howard at Colorado State, both mentioned liver abscesses. You can see their second point, they both mentioned the red meat yield concern. The third individual I reached out, but I didn't get this in the slide in time, was Blake Foraker. Blake was recently at Tech, but now is at Washington State. His top 2 concerns were actually the same as these 2, and he added something that I'm just going to read. I'm going to share with you a quote from Blake because I think he went a little Willy Wonka on us, and I think it's really important. Blake's quote was, marry the right management system with the bull that addresses both of those challenges, and you have the golden ticket. Both of those challenges, meaning liver abscesses and red meat yield. But the tools to do that from a genetic standpoint just simply don't exist today. And also he mentioned that the cow is still half the equation, and nobody's explored her influence to this point. So I think what you're seeing is from 3 folks who are meshed in this every day. They're telling us, going back to my earlier question, is as an accountant in the beef on dairy space, are we accounting for all the major economic hurdles in the current beef on dairy indexes? And probably not. And I think these are areas we're going to have to think about helping from a novel trait development standpoint if we're going to incorporate and do this effectively. So with that said, to quickly wrap up, my contention is packers need answers. And that's great. Genetic eval can go a long ways to help, and many of those packers know, and I know that very clearly. And so to wrap down to the bottom line, we love to talk about genomic pipelines. We live in a world where things like genomic pipelines, when it's relative to genetic evaluation, are all the rage, and appropriately so. But in this case, along with those genotypes, we are going to have to develop some phenotypic pipelines to get some of this data in so we can help them solve their dilemma, solve their challenges. And I think it's a great opportunity for all of us to work together as neighbors and partners in this business. With that, I've tried to move through that pretty quick. Dr. Spangler, I am going to stop there and I'll let you throw questions.
Thank you, Chip. I appreciate that. We'll get to the Q&A here. It looks like we've got most of those handled. Any questions for Chip? And then if there are questions for Scott, additional questions for Scott, we can handle those now as well. If you just use either the chat box or the Q&A box. While we're waiting for those, I guess I've got maybe a question or 2 to start with while we wait for additional questions to come in. Chip, just to make sure I track correctly, you mentioned the concern over red meat yield, and particularly the yield grade equation's ability to predict that in beef on dairy. And I think you made the comment that measuring the ribeye as we do, there might be a less weight in the chuck and round and beef on dairy crosses than what we might predict. Where I'm getting to is if a native beef animal has the same carcass weight as a beef on dairy animal, right? And there's less weight in the chuck and round on the beef on dairy, where's the additional weight at? Am I making sense?
Yeah, absolutely. Or to me, you make sense, and let's hope I interpreted it correctly so you agree with me. I think one of the things that you're seeing from some of the work that Dr. Warner and Dr. Foraker have done is that there's a slight different proportion at times betwixt the bone and the fat components within the beef on dairy than maybe what you would traditionally see in the natives. And in particular, there seems to be a wide disparity in the beef on dairies, meaning there are some who are essentially replicates of native beef calves, and others, as you would surmise, are much closer to the infamous black Holstein in this space. And so that I think is how they would explain that. I think some of that work that they've done initially has shown those things. And so it's those other tissues that are kind of shaking that up just a little bit so that it doesn't track quite as clean when you just use ribeye as a proxy for a whole body muscle.
Okay, thank you. Question from the Q&A box. The last meat scientist you asked, where is he located?
Blake recently moved to Washington State University.
And then another question came in here. Are there any attempts to collaborate with CB on developing new traits for beef by dairy evaluations? They have excelled in phenotype pipelines, in part because the nature of the way dairy record keeping works, and could at least provide a foundational model on the dairy side.
Absolutely. The basic contention there that dairy folks share data more effectively is no question accurate. I think the pipelines that the linchpin, or maybe the holdup maybe, is getting this carcass data is not something that's ever really went into that eval either. And those are the areas where we're going to have to find new structures to get that data on a more consistent basis, and hopefully with some genotypes. So the short answer is yes, those conversations have been had with that group, but I think specifically relative to the terminal metrics, we've probably got a little ways to go to talk with the folks who control those.
And maybe just one more question here for you, Chip. If we put selection pressure on red meat and fat, does that have to come at the expense of bone?
Well, from a percentage standpoint, I guess it does, because, in terms of just raw poundage, maybe or maybe not, I guess it depends upon how hard you want to put pressure on bone. But from a percentage of a carcass standpoint, which is often how a packer is going to think, then by definition, if we added more muscle, if we added more fat, from a percentage standpoint, we'd lessen the amount of bone in that carcass.
Okay, well, I'm sure these two gentlemen would be happy to take questions offline as well, if any of you do have remaining questions. I would like to remind the group that our second session will be a week from today, October 12th at noon Central. Your host that day will be Dr. Dare Bullock from the University of Kentucky. Our speakers, Ms. Kelly Ritalik, who's the president of Angus Genetics, Inc., will talk about selection for female fertility, updates from the American Angus. And then Dr. Rob Banks, Maritime Professor from the University of New England in Armidale, Australia, will talk about funding continued data collection and genetic improvement. Dr. Banks has some really novel thoughts on how such a mechanism might work, and has given this a lot of consideration. So I think a very interesting viewpoint there. So with that, I'd like to thank you all for joining, and look forward to seeing you back here at noon Central next week.